I welcome you all for Standard 7 subject General Science. Students, we will be doing with chapter number 6, Measurement of Physical Quantities. My name is Ms. Jagjeet Kaur. Now, before beginning with the chapter, let us see what are the learning objectives. Now, students, in this chapter, you will be understanding about physical quantity, then what are standardized measurement and what are the fundamental quantities. Then you will be also understanding about international system of units and what are the importance of accurate measurement and what all are the major causes of errors in the measurement. Now students, observe and discuss that how are the various articles and materials shown in the picture measured. Now to answer this, we will have a table with 3 columns, that is the first column is article and material. Then the second column is physical quantity in which it is measured, and the third column is units of measurement. So the first article is brinjal, which is also vegetable. Now brinjal is measured, the physical quantity in which brinjal is measured is mass and the unit of measurement is kilogram. Then the second article is reel of thread. Physical quantity in which reel of thread is measured is length and the unit of measurement is meter. Now the third article, leafy vegetable. Now students, leafy vegetable is not measured in the physical quantity. That means the physical quantity in which leafy vegetable measured is not there. But the unit of measurement is like per piece, that is the bundle of vegetable. Then the fourth article is liquid. Now the physical quantity in which liquid is measured is volume and the unit of measurement is liter. Then the fifth article is ornament. Physical quantity in which ornament is measured is purity or mass, and unit of measurement for purity is carat and for mass is gram. Then the last article, that is the sixth article, is fabric bolt, which is also called as rolls of cloth fabric. Now the physical quantity in which rolls of cloth fabric is measured is length and the unit of measurement is meter. Now students, let us understand about physical quantity. The various quantities in day-to-day life which can be measured are called as physical quantities. For example, mass, distance, velocity, etc. A value and a unit are used to express the magnitude of a physical quantity. For example, Swarali walks 2 kilometers every day. Now students, in this example, 2 is the value and kilometer is the unit used to express the magnitude of the distance, which is a physical quantity. Then a quantity that can be completely expressed by its magnitude alone is called a scalar quantity. For example, only magnitude, that is a value with a unit, is used to express quantities such as length, breadth, area, mass, temperature, density, time, work, volume, speed, etc. Thus, we say that the length of a tunnel is 2 kilometers. And the next example is that the fever, that is the temperature, is 101 degree Fahrenheit, etc. Then the quantity that is expressed completely only when magnitude and direction are both given is called a vector quantity. Now displacement, velocity are vector quantities. For example, a displacement of 20 kilometers towards the north, the aeroplane flying at a velocity of 500 km per hour towards Mumbai, and also thrust and temperature change are vector quantities. Then students, different physical quantities are measured using different units. And the amount of matter present in a substance is called mass. Matter has a natural tendency to resist a change in its state, which is called inertia. And mass is the qualitative measure of the inertia of an object. The larger the mass, the greater is the inertia. And mass is a scalar quantity. It does not change from place to place anywhere in the world. The quantities mass and weight are however different. Gram and kilogram are the units of mass, and when we use the two-pan common balance in a shop, we compare two mass. Then students, what we measure in grams, kilograms is mass and not weight. So the gravitational force that acts on this mass is called its weight. That means we can say that weight of an object is the gravitational force that acts on its mass. Then weight is a vector quantity and it changes from place to place, and unit of weight is Newton in MKS system and dyne in CGS system. Now students, use your brain power to answer this question, that why would the weight of an object be maximum at the poles and minimum at the equator? Yes, the gravitational force by which the earth attracts an object towards its center is the weight of the object, and earth is flattened at the poles and bulges out at the equator. That is, its poles are at shorter distance from the center than the equator. And due to this, gravitational force exerted by the earth on the object at pole is more than the gravitational force exerted on the same object when it is placed at equator. And as a result, an object weighs more at poles than the equator. Now the next question is, why is the weight of an object at a high altitude less than its weight at the sea level? Yes, the gravitational force by which the earth attracts an object towards its center is the weight of an object, and the distance of an object at an altitude from center of the earth is greater than that at sea level. And due to this, the gravitational force exerted by the earth on the object at sea level is more than the gravitational force exerted on the same object when it is placed at a high altitude. And as a result, an object weighs less at a high altitude than at the sea level. Now students, do you know that one body has weight because of the gravitational force of the earth? And the gravitational force of the moon being less, our weight will turn out to be less there. But our mass, however, is the same at both the places. Now students, we will understand about standardized measurement. For that, we will do one activity. Now you can take a ball of string. Let one student from the class measure 4 hand spans of the string and cut it there. Then let each of the other students in the class cut 4 hand spans of the string too. Now hold all the pieces together by one end. Are they all of the same length? Correct, you are correct. No, they all are of different length. Students, now measure the length of a bench by means of the span of your hand. Ask your friends to do the same. Did each of you obtain the same measure for that bench? What could be the reason? Correct. We did not obtain the same measure for that bench. So, the measure of the bench is not same, it is different, and length of each person's hand is different. It is not a standard unit of length. So, hence, when same length is measured by different persons, it gives different values of measurement. Now, what are standardized measurement? The process of checking things against a standard measure from time to time is called standardization. And standardized measures are required for measuring physical quantities accurately, and such measures are called standard units. For example, the meter, which is written as m, is the specified unit for measuring length. A certain distance has been accepted as a standard for 1.0 meter. Now students, the span of a hand is accepted as the unit for measuring length. Now with this unit, we can measure lengths of clothes as 2 hand spans, 3 hand spans and so on. However, the lengths of the cloth measured by each one of us will come out to be different. That is why a handspan cannot be a standard unit for measuring length. Now students, you have to always remember that prevailing systems of management are MKS system and CGS system. Now what is MKS system? In this system, distance is measured in meters, mass in kilograms and time in seconds. And in CGS system, distance is measured in centimeters, mass in grams and time in seconds. And also in the MKS system of measurement, distance, mass and time are accepted as the fundamental quantities. And these three quantities are used to measure all other quantities. Now students will just complete this table. The physical quantities are given and we will be understanding what is the MKS and what is CGS unit for that particular physical quantity. Now for mass, MKS unit is kilogram and CGS unit is gram. For distance, MKS unit is meter and CGS unit is centimeter. For time, MKS unit is second and also same as in CGS unit, the time is second. And the MKS unit for speed is meter per second and the CGS unit for speed is centimeter per second. Now let's learn about fundamental quantities. Though there are many physical quantities, it is sufficient to select a few out of these quantities and standardize their units. Such quantities are called fundamental quantities. Then mass, length, time are some of the fundamental quantities. Physical quantities other than fundamental quantities are called as derived quantities. And derived quantities depend on fundamental quantities and can be expressed using combinations of fundamental quantities. Example, speed is equal to distance upon time and volume is equal to length q. And each fundamental quantity has a standard fundamental unit which is invariable and available to all. For example, fundamental unit of time is second. Now measuring a quantity accurately is important, and a solid cylinder made of platinum iridium alloy is kept in the International Bureau of Weights and Measures at Paris. This mass, as per international agreement, is called 1 kilogram. And the distance between the two fine lines engraved on a platinum iridium bar kept at the International Bureau of Weights and Measures Paris is accepted as a standard meter. And second is standardized by considering the time taken by Earth for one revolution in as 24 hours. And 1 hour is further considered to have 60 minutes and 1 minute to have 60 seconds. Now let's understand about the international system of units. An international system of units based on 7 fundamental units called the System International, that is SI, is currently used all over the world. It is also called the metric system. The names and symbols of the units of the fundamental quantities, length, time, and mass in this system are given in the following table. So, the name of the unit for length is meter and the symbol of the unit for length is m. The name of the unit for mass is kilogram and the symbol of the unit for mass is kg. The name of the unit for time is second and symbol of the unit for time is S. Now students, find out what is an atomic clock and where is it kept. Yes, to measure any time interval a clock is needed, and nowadays atomic standard of time is used for the measurement of time. And in atomic clock, to measure time, periodic vibrations of cesium atom is used as a standard. And 1 second is the time required for 9, 192, 631, 770 vibrations of cesium atomic clock. The cesium atomic clocks are very accurate, and in India, IST, that is Indian Standard Time, is maintained with the help of 5 atomic clocks kept in National Physical Laboratory, that is NPL, in Delhi. Now students, in the past, when man felt the need to measure things, he started by using the parts of his own body for the purpose. In Egypt, in ancient times, the distance from a man's elbow to the tip of his middle finger was called a qubit, and this measure would differ from person to person. The qubit of the king was considered as a standard, and in olden times, we weighed gold in a unit called gunj. An hourglass was used for measuring time. Now students, observe and discuss and identify the wrong methods of measurement shown in the picture and explain why they are wrong. So in picture 1, measuring length using length of hand as measure is inappropriate, because as length of hand is variable and not a standard unit of measurement. Now in picture 2, measuring length using ruler is correct, as ruler is a standard unit of measurement and invariable. However, it is standard convention to coincide one of the end points of the line segment with the 0 mark of scale. Thus, picture 2A is inappropriate and picture 2B is correct. Now we come to the picture 3. Measuring volume of liquid using any two glasses is inappropriate, as volume of glass is variable and not a standard unit of measurement. Instead, a measuring cylinder can be used. And in picture 4, measuring mass using a weighing scale is correct, provided the weights and balance are standardized. Now, what is the importance of accurate measurement? Now, accuracy in measurement of a quantity depends on the purpose of measurement, and measurements carried out for certain purposes must be highly accurate. And also, error in measuring chemical constituents of a medicine may prove fatal, and error in measuring precious substances such as gold may lead to significant errors in financial transactions. Then accuracy of measurement also depends upon the device used for measurement, and an appropriate device should be chosen and should always be checked against the corresponding standard measure from time to time to ensure accuracy. And also the device should be handled meticulously so that no error is introduced. Now students, while making measurements, multiple errors may occur. And major causes of errors are not using the appropriate device. That is, accuracy of measurement depends on how appropriate the device is. For example, to check a weight of a person instead of analog weighing machine, that is machine that has a graduated scale of weight and a pointer to indicate the division on scale, a digital weighing machine can be used. Then the second major cause of error can be not using the device properly. If the device is not handled properly while taking measurement, an error will get introduced. For example, while measuring length of line segment with scale, it is essential to check whether the zero mark of scale coincides with one of the endpoints of the line segment. Then the third major cause of errors in measurement can be not using standardized device. That is, it is essential to check device against a standard measure from time to time. For example, if weights used at grocery shops are not compared with standard weights, measurements done using such weights could be inaccurate. And the Urban Supply and Consumer Protection Division of the government has appointed a weights and measures subdivision to keep a check on the weights and balances being used at different places. It also grants licenses for the production, sales, and repairs of weights and measures. So students, this was the end of the chapter. Now let us summarize what we have learned in this chapter. So we learned that the various quantities in day-to-day life which can be measured are called as physical quantities. And a quantity that can be completely expressed by its magnitude alone is called a scalar quantity. And the quantity that is expressed completely only when magnitude and direction are both given is called a vector quantity. And the amount of matter present in a substance is called mass. It is a qualitative measure of the inertia of an object, and also it is a scalar quantity. Gram and kilogram are the units of mass. Then we studied about weight. Weight of an object is a gravitational force that acts on its mass. It is a vector quantity and unit of weight is Newton in MKS system and dyne in CGS system. Then we also learned that the process of checking things against a standard measure from time to time is called standardization, and standardized measures are required for measuring physical quantities accurately. Such measures are called standard units. And though there are many physical quantities, it is sufficient to select a few out of these quantities and standardize their units. Such quantities are called fundamental quantities. An international system of units based on 7 fundamental units called the System International, that is SI, or metric system is used all over the world. Thank you, dear students.